All right, so we're talking today about basic percent and uniform motion later on, but right now basic percent. So we're going to talk about just basic percents. We're going to solve applications here using the basic percent equation. And the book talks about using the basic percent equation. We'll talk about that. We'll talk about other ways to solve it as well, solve percents. We're also going to talk about uniform motion problems, but that'll be later in in I guess future videos. So the basic percent equation is this one here. That's what the book talks about. Basic percent equation talks about the percent times the base equals an amount. P times B equals amount. Percent in terms of not percent like 50%. 50% here would have to be translated into 0.5 into our equation. Remember, percent is a description. 0.5 is a more mathematical term. The base we'd have to figure out. The amount A is an amount that we have to uh, find from each description. So there's one way to do it. Another way to do it that some people might be familiar with would be is to of as percent is to 100. Basically, you set up a proportion and you cross multiply. You multiply the is times the 100, you multiply the of times the percent, and you solve that way. And that's a different way to look at it, because a lot of times you talk about descriptions using is and of and percents and 100. 100 always goes here. Um, and that's a different way to look at it. A similar way would be part is to whole as percent is to 100. These are essentially the same, these two, because the is the part of whatever you're talking about. The of is the whole of whatever you're talking about, and the 100 is 100, and percent is percent. And you solve for any one of these, part or whole or percent in the green, or in the black you solve for is or of or percent. We'll talk about these a little bit more in detail uh, later on. But again, for the black or the green, essentially you got to cross multiply. Is times 100 equals of times percent, or part times 100 is whole times percent. Green and black are essentially the same. It's just a different way of looking at the is as the of, or the part and the whole. And the last one is just kind of taking a look at translating a sentence into an equation. So you could do that as well. And we'll talk about each one of these individually as we go along. Okay, so if we're talking about bases and percents, remember here's our basic percent equation. Basic percent equation is right down here. Percent times the base equals the amount. Percent times the base equals the amount. That's the basic percent equation that's described in the book. So all of these up here are essentially the same description, just in different formats. 5 is 50% of 100. 5 is 50% of, or sorry, of 10. 50% of 10 is 5. Says the same thing as that. Of 10, 50% is 5. Says the same thing as these. And all these are also exactly the same. 5 of 10 is 50%. 50% is 5 of 10. All these are exactly the same, and all we have to do is pull out the information from here to say that our percent, if we're looking at setting either of these, any of these statements that are exactly the same, just in different formats, if we want to set these up in the percent, basic percent equation, we think about of is the base. Of the base is of 10, of 10, of 10, of 10, of 10, of 10. The of 10 is always going to be there. So we'll have of the base. If it's of some number, of what number, then we have to remember that the base would be our unknown, and we solve for that. So we're going to set this up as any of these really are going to be set up through the basic percent equation as percent would be 50%, so 0.5, you could put 0 if you want, multiplied by the base of 10 times 10 equals the amount. Whatever amount is left is that amount, the amount that goes here. So 5 is the only number that's left over, so we put 5 right here. 0.5 times 10 equals 5. That sounds correct. And if we said, if we replace this of 10 up here with of what number, we'd say 0.5 of what number, that base, equals 5. And we'd solve that way. We'd solve by dividing by 0.5. 0.5 base equals 5 divided by 0.5 is 10. Base equals 10. And that's the way we'd solve it. If we're going to follow the is to of rule, remember is to of as percent is to 100. This is the different is to of approach. Let's take this one, because this one is, we kind of translated that one, but remember all these are equivalent statements. They're just kind of things are put in different order. But let's take a look at this one and say is to of as percent is to 100. Okay, well 5 is, so the 5 goes into the is spot. Of 10 goes right here. Of 10 equals 50%. 50% goes right there of 100. And from here you'd cross multiply. 5 times 10, sorry, it's 5 times 100 equals 10 times 50. 500 on the left equals 500 on the right. Sure enough, that's a true statement. And if we said, so this is just translating this equation or this statement into this is to of statement. But if we didn't know what the base was, of what number? If we said 5 is 50% of what number, we'd say 5 is, let's see, 50%, 50 goes here, of 100 always goes there, because we're just moving this stuff over here and filling in some numbers from this red statement here. And we're pretending that we don't know what that 10 is. If the question were 5 is 50% of what number, 5 is 50%, 100 always goes here, of what number? X. Alright, so now from here we just cross multiply. 5 times 100 equals 50 times x. And now we solve that equation. 500 equals 50x. Divide by 50 on each side. Divide by 50 on each side. X equals 500 divided by 50, 10. Done. And we could solve for my x as my unknown, my of value of what number? 10. There's two different ways, and I'm going to recommend probably one of those two ways to solve those equations. 5 is, use the is to of as percent is to 100 on the right side, or use the PBA method, and percent times the base equals the amount. Either way, you get to the same answer. Whatever you feel comfortable with, go ahead and use that.